Okay, great. So sorry for the slight delay. Okay, so function. So today we're discussing function, from built-in functions to defining custom functions to some great use of functions, recursion especially. Okay, so a function. What is a function? On one hand, you can think of a function as a processing machine that accepts raw inputs, processes it, and produces refined output. Now, the events or activities that took place inside the function is not known, not like we care really, but it still produces the desired output. So that's how functions are meant to work. On the other hand, we can also think of function in terms of mathematics as an expression that accepts an input or a series of inputs, then applies certain operations to them to produce output. So I have the two illustrations here, one as a machine, the other as a mathematical function. Think of both of them as almost identical or the same thing, not almost even, they are the same thing. So here we're passing in inputs. Assume this input is our x in mathematical term. So, and we're getting outputs here, and this is the function machine. So the outputs you are getting is what we're going to have on the other side of the equation here. And this f of x here is the function machine. Okay, so let's move on. Built-in function. So what is a built-in function? Before this class, we have made use of built-in functions at different times over the course of the classes so far. So we're going to examine what built-in functions are, and we in particular going to see the ones we have used before now. We're still going to try to use few of the other existing built-in functions. So built-in functions are functions that have been predefined by the interpreter of the language. So understand it as the people that made the language have sensed that people would need this function, and they have built these functions into the interpreter. So it just comes out of the box. Okay, so, oh, sorry, let me quickly edit this. Okay, so examples that we have encountered in the past lectures include print function, zip function, range function, type function, string, int, float, open, len, eval. So these are some of the examples we have encountered from the previous classes. Print should be the most obvious of all of them here, and range should also be one of the obvious ones. Then the type function, then the string, int. I've used zip function one or twice. I've used open function once. I've used the len function one or few times. The eval function a number of times. It's input. So there's also input function I forgot to mention. Let me just quickly add it here. So there's input function as well. Okay. Oh, I added it at the wrong place. Okay, so now these functions, we have so many of them, even the built-in functions. We have so many of them. I've only listed a handful here. I left a link where you can check and see the very many other functions we have. Let me share. Can you see my screen?
Yes.
Yes.
So I'm on w3schools.com. So they have a list of so many other functions that are built into Python. Absolute, the all, any, ASCII, bin, bool, so many of them. You can see it's a very long list. And most likely you wouldn't be using many of them. I still can count a number of them that I've never used. Okay, so now we have some, excuse me, please. We're giving some examples of built-in functions. So print function is the most obvious of all of them. And there it is, we're also using it. So I call the print function, I passed in my inputs. This is one of the inputs. Think of this input as a raw material. This is another input here. The end parameter is another input that I'm passing in. So I pass in two inputs and it produced I am a happy person with a full stop. So the inputs are disjoints, they are separate, and it was able to produce something entirely different from what I passed into it. Remember, I passed two things and it produced one thing. So going forward, we have zip function. So let's see how zip function works. I've used it before. This is an opportunity for you to grab how zip function works. So a zip function. So I pass in, here it is, I pass in two lists. This is the first, 1, 2, 4, and the second list is a list of strings, shoe, bag, and dress. And I call a zip function on both of them. I pass the two separate lists in. So now here I have a slight description of what zip does. A zip object, okay, it produces a zip object. So I'm passing this zip to zipped. So I'm now explaining that a zip object is a generator object. It does not return a human readable output when printed. So here I'm printing it, and here is another is a for loop I'm using to generate the content of the zip. In the next code cell, you're going to understand further what is happening here. So now this is me printing the zipped function as is. As is. It simply produced, this is a zip object, and this is what it produced. Nothing readable, right? But the computer understands it. So now this is me, this for loop. This is me trying to get the contents of the zipped object. So, and I'm looping through it. So the zipped object is a generator object. So a generator, what it means is it generates values on the fly. However, the value has been instantiated here. So it's now going to generate them on the fly. So now I'm looping through it and I'm producing each of it. So now let's see what the zip did. I can see 1 and shoe here, 2 and bag, 4 and dress. So if we go back to the separate list we passed into it, if we look carefully, we'll see that corresponding index items in the two lists are matched together as a tuple. So this is a tuple, a tuple pair. So 1 and shoe is mapped together, 2 and bag zipped together, 4 and dress zipped together. So that is what happened in this zip function, or that is what the zip does. So now let's still continue. I'm trying to make a correction here, please. Okay, so here, list function, this is another function. A function that allows you to convert certain objects to lists. Certain objects to lists. So in this situation, we're trying to convert the generator object that we created here with zip into a list. So the list function allows us to do that. I'm still going to show another illustration of what the list function allows us to do. But in this example, we have created a zip object like we did in previous. So here, we're trying to convert the zipped object into a list object. I'm passing it to another another variable object, zip to list, and we're printing it out. So there it is. Now we can see how zip creates memory of the two objects that is passed to it, or whatever number of objects. You're not limited to 2 objects. You could pass in more here. But one thing that you have to take note is, I'm going to write it here, the length of the iterables you pass. The iterables are the list. Here, this is a list, 1, 2, 4, and this is another list, shoe, bag, dress. The lists are called iterables. So the length of the iterables must be equal. The length of the iterables that are passed to the zip function must be equal. Let me bring these. Okay, it's fine. So must be equal. So we can easily see that 1, 2, 4 is 3, shoe, bag, dress is 3, and they're equal. If they are not equal, we're going to get an error. So, and what the computer simply does is it matches the corresponding index items from both lists. Okay, so I promised I was going to show another use of lists. In order to convert the characters of a string into lists, we can call list function on the string. So here, let's create a string and call it hello world. So we now call list on string, and there it is. It has created a list with a list of all the characters in the world in the word hello world. Okay, so another function we're examining here is round function. So I urge you to explore the other functions that I'm unable to list out here. That was why I provided the link here to W3 School, where you can see the other options, the other functions, built-in functions, and their uses. So you'll see them, and if you click on each of the, let me still open it once again. So if I want to know how to use a dict function, for instance, so I'll click on this dict. It provides a slide summary here, but I'll nonetheless click on dict and wait for it to load. So there it is, Python dict function. It's a built-in function. Example, create a dictionary containing personal information. You can actually try it yourself by clicking on try it yourself. It takes you to another tab where you can run the example code and even modify it. So I'm running it. Okay, so there it is. So I can actually change a lot of things here. If I wanted to change this to Joseph instead, it's still going to work, and I run it. So it has changed to Joseph here. Okay, so going back. Okay, so now round function is the other function we are examining here. It is used to round numbers to a given precision in decimal digits. So here I create a variable 45 point. I create a variable and assign 45.6783 to it. And here I round it up to the nearest whole number without passing any other parameter. I just simply pass in the number and Python knows well to round it to the nearest whole number. But what is happening here, if you look at the second print statement, the output says rounding number to 2 decimal places, and it rounds it to 2 decimal places. And that is because I've passed in a second argument here that specifies that I want it rounded to 2 decimal places. So there's a function I forgot to add that is actually a very useful one, and that is the help function. So I'll add it here. Help function. So help function is used to, it just serves the purpose of its name, help. It's used to get help. So if I call help function and let's assume there is a built-in function and I don't know how it works. So let me pass in round. I want to know how round function works. So I'll simply call help and pass round into it and wait for it to load. So there it is, it explains help on built-in function round in module built-in. You can ignore this and simply go here. So here it tells me round. This is the syntax. So these are the parameters it takes. It takes the number you want to round, which is the most important parameter you have to pass in. Then it takes the number of digits you want it to produce. Remember, you're rounding to decimal place. So the number of digits after the decimal, you pass it in here. So if you want 2, as in our example here, you pass in 2. Okay, so that is help function for you. You could pass in so many other functions to it. Help, print, and you also get the output. So it tells you, it provides help on round, provides help on print. So now, we are done defining built-in functions. So I'm going to introduce you to defining custom functions. So custom functions allows you to do a host of, or to create functions that that does something, that takes in an input and provides output for you. Basically, just the way the built-in functions work. But here you have the flexibility of defining the function as you wish. Okay, so let's see the syntax. So it starts by you writing def. So def is what tells the computer, okay, this line is the start of a function. So you define the name of your function. So you have to specify the name in place of this my function. Remember, variable names in Python or in most programming languages for that matter cannot be space separated, cannot be separated by space. So I couldn't have written my with space here. So that's why I wrote it as my function without space. So you initiate it by writing def, the name of your function, you open a parenthesis and pass in the arguments of that function. This argument is optional. This argument is optional. So I'm emphasizing on that. We're going to see it in code in the next cell. Yeah. So after creating the name and closing the bracket, remember to mark it off with a full column. Just as you do with the if statement, the first statement that you mark off with a full column before you go to the next line. In a function or in defining a custom function, you also mark off the first line of the function with a colon. Then indentation is very, very important. So you create your indentation and you pass in, or you type in some statements or some expressions for it to execute. Then, optionally, you can provide a return value if you want it to return a value. So the following examples illustrate defining a function. So we shall look into the examples when we return from, or when we join the second session. Thank you.